Episode 10 of the Torque Factor podcast is here, and I'm your host, Scott Brown. This is a place where we discuss all things moving the automotive service industry forward with a goal of expanding knowledge and awareness around tools, equipment, education, and industry trends. This episode's featured guest is Dr. Mark Quarto with Quarto Technical Services and Future Tech Auto. Mark is a subject matter expert on advanced vehicle propulsion systems and technologies. Mark and I discuss Tesla and review the recent Battery Day event, Tesla's electric machines and how they differ from the rest of the market, and also discuss Tesla as a vehicle manufacturer and why they currently possess an advantage over other automakers. We'll also discuss legacy knowledge and what tomorrow's technician will need to do to prepare for future technologies. This episode is sponsored in part by Bolt-On Technology and VehicleServicePros.com. Please consider thanking them for helping us bring this show to life. VehicleServicePros.com is a trusted online resource for vehicle service and repair information, fleet maintenance management, and the latest products for servicing America's fleet of vehicles. It is the official website of professional tool and equipment news, fleet maintenance, and professional distributor magazines. VehicleServicePros.com is on the pulse of the industry, sharing new technology, the latest product information, and market trends to keep our readers in the know-how. Shops everywhere are shifting into high gear with NextGear. Bolt-On Technology's game-changing tools are now available to any shop, anytime, anywhere. So every automotive professional can tap into Bolt-On's digital vehicle inspections, two-way texting, and advanced appointment setting tools with just a smartphone or a tablet. No additional equipment is needed. Plus, the second gear text-to-pay feature is included to NextGear customers at no extra cost. At Bolt-On Technology, their gears never stop turning. Learn more at www.nextgearnow.com. All right, that brings us to our recall segment, and we get all of our recall information from the NHTSA.gov site. Highly recommend that you check all the cars coming through your service facility for open recall so you can keep your customers safe. So we're going to talk about one recall in particular. This is a 20 Victor-512. Kind of interesting. 2018 to 2020 Dodge Pursuit vehicle. So these are police type vehicles. And the ones that are equipped with what's called a stealth mode so that all the lights are out. And so at night, it's in stealth mode. These vehicles actually have, of course, a backup camera. And when they go into stealth mode, the backup camera display does not work, which unfortunately is a violation of the Federal Motor Vehicle Safety Standards. So what FCA will be doing is reaching out to clients or customers that own these vehicles, and they'll be reprogramming the body control module in that vehicle to make them compliant and make them just a little bit less stealthy. All right, that brings us to our case study segment. And this case study, again, comes from Diagnostic Network. And this one in particular is from Bernie Thompson with Automotive Test Solutions. This guy posts a lot of really cool stuff. He's an awesome problem solver. He does a lot of mobile diagnostic support for shops. And in this particular one, he's got about a 13-minute video, and I'm going to leave a link in the show notes here, but you got to check this thing out. If you're a diag tech, you'll really appreciate this because he goes into studying why this vehicle had multiple ignition coils, which is a cassette assembly, which also includes the ignition module for each coil. And the vehicles had multiple modules replaced. And what they do is they replace it to solve a misfire. It stops missing for just a short period of time and then starts missing again. And he uses he suspected he had a problem, and there was a short on the power supply side. So there was a power side short in this ignition coil control system. And he walks through how he used the scope to figure out what's going on. Inside of their scope, they actually have a signal generator that they can push out a signal, and so they can help to try to identify where a particular problem is. So anyhow, that's an awesome case study, so I recommend that you go check that out. And all right, that brings us to our featured guest, I had Dr. Mark Quarto, who is an electrification subject matter expert. He is from Quarto Technical Services. He and I engaged in a pretty lengthy conversation where we talked about Tesla's battery day. We talked about Tesla's propulsion systems, and then how they are operating as a vehicle manufacturer that's significantly different than most other manufacturers out there. So let's have a listen. So today, ladies and gentlemen, I'm pleased to present Dr. Mark Quarto. He's a subject matter expert on this advanced propulsion systems and advanced vehicle systems. He's an engineer, he's an instructor, he's a consultant, and I've had the pleasure of working with Mark on various projects. And I really wanted to get him on the call to talk about Tesla and what Tesla has unveiled recently with their Tesla Battery Day. So first, welcome to the call, Mark.
Well, thank you so much, Scott. I appreciate the invite. And I know it's kind of been a long time coming. We've been trying to sync up, over time. So it's a pleasure to finally sync up with you. I appreciate the opportunity.
Well, great. Yeah, I know you've got a lot of really good knowledge, a lot to share. And so let's get right into it. So Tesla on September 22nd this year, 2020, they held their Battery Day. I don't know if you recall, but over a year ago, they held the Tesla Autonomy Day, where they unveiled a lot of their advanced driver assistance stuff, and it was pretty revealing. But this event, of course, due to COVID, was kind of unique. They held it outdoors and had it like a drive-in theater. But I found the information there was just overwhelming. For me, I was trying to stay connected and try to understand what was being discussed. And as I was listening, I'm going, oh my gosh, I'll bet you Mark has a lot to really help uncover here. And I think for our listeners, will love to hear some of this, because this is the future. But I found a quote from Forbes that basically kind of summed up the day that Tesla revealed their new technology on the battery system. So it says, overall, Tesla is predicting a 56% total reduction in cost per kilowatt hour of the battery pack, and resulting in a 54% increase in range for the same size battery pack. They also claim a significant reduction in the footprint of the factories and the costs of scaling of production. They're predicting 69% less investment needed. So that, to me, is that's earth-shattering. And since you used to work for General Motors and you've got relationships out there, I can anticipate that you probably have a lot more perspective there, and I don't know how much you can talk about there, but let's talk for a minute about what did they just do. They talked about this new battery. It's a 46 by 80 millimeter. They also claimed this new tabless design, which I did some reading on, but I'm not sure exactly what the benefits there are. So can you walk us through some of this?
Sure. What I'd like to do first is I'd like to talk a little bit about how Tesla is structured, because that really impacts what they're able to do. So let me kind of give some perspective on that, because that really kind of drives where they're at. So if you take a look at it, Tesla is a vertically integrated company, which means everything that they do, basically they manufacture. I mean, they have everything underneath that. They don't really outsource much of anything. There is some outsourcing, of course. Nobody does everything, but they're very limited on that compared to the other OEs. So if you take a look at a Ford or a VW or an FCA or even a GM vehicle, you end up with horizontal integration. So let me go through vertical first. So vertical means that you have all of your manufacturing, you're doing everything in-house, so to speak, most everything anyway. Now, a horizontal company, on the other hand, what a horizontal company does is they really outsource everything. They've got partners, so they go across horizontally. So they have a battery pack supplier, maybe propulsion systems and so on. They kind of go across rather than up and down. So if you take a look at it, and let me just kind of give you a little history here. GM was very vertically integrated where I come from. They were very vertically integrated years ago. They had They did powertrain, they did their engine and transmissions and axles. Rochester Products did fuel systems, emissions. Delco Electronics did all the controllers. Delco Remy did all the electrical, and there was suspension there. Delco Marine did brakes. Harrison Radiator did, HVAC. Fisher Body did the body. So way back in time, most of the other OEs, if you go back, somewhere between 30 and 60 years ago, they were all vertically integrated. And it enables you to do a lot of things on the fly. And so you don't have to go to a supplier and say, gee, would you change this for me? And then of course you have to go back and forth contractually, and there's a lot of time burned in doing that. And then you don't own the intellectual property. That's the other thing. You don't own any of the IP. So when you're vertically integrated, like Tesla is, you do things on the fly. You can do things on the fly because you own the intellectual property, you own the manufacturing, you can switch things up at any particular time. So you can be more creative that way. And Tesla is very creative because they are vertically integrated. And if I could just bring in one other piece here, they have SpaceX over on the other side, and SpaceX was formed in, I think, about 2002. So I don't know this for a fact, but if I had to bet my life on it, I'm sure I'd be right, is that they are leveraging a lot of SpaceX technology into their vehicle. So not everything, of course, but when you get into the materials part of it, you get into frame structure, body structure, you get into the materials that make up, motors, inverters, and things like that. You can get into some pretty creative things by being vertically integrated, because you can just kind of go back and forth in between your disciplines, where when you're horizontally connected, you can't do that. So let's say, for example, you've got a Ford who might be using Panasonic batteries. They might be using Aisin or Hitachi or somebody else as their supplier, maybe for their power products and so on. You kind of go across, and you're dependent upon them for your creativity. And Tesla doesn't have that. They're all vertical, which means they can do things as fast or slow as they want. They can integrate or not integrate something. So they really have an advantage here in being vertically integrated. Now, I will also tell you that, speaking to some of my former colleagues and also others within the industry, is that I think Tesla is going to drive companies to go back to being vertically integrated. Now, this is going to take a lot of time, because it took a lot of time to decouple from going from vertically integrated to horizontal, which means you end up selling off a lot of you spin off, like, GM spun off a lot of their Delco and Delco Electronics and Delco stuff over into Delphi. I mean, that's who Delphi is today. They're an old GM spinoff. So it takes a long time to become vertically integrated. And so we're going through this cycle right now where most companies are horizontally integrated, with the exception of Tesla. So I think a lot of Tesla's power comes from its creative powers, and its ability to innovate come from the fact that they're vertically integrated and they get to leverage SpaceX. So I think there's a huge advantage that they have there over others. So I think that's why you're seeing a lot of innovation coming from them quickly, because they're able to do that, and they're not dependent upon their suppliers.
Yeah, I see that is huge. I mean, that's a great analogy there. They're able to pivot on a dime, and
they are. Yeah.
And you can see what has happened over the years, right? And why a company may have switched and sold out some of their assets, and then it turns into a horizontally leveraged property, which means that there's a time instance, right? So now, like you were saying, you want to change a design plan. Well, now that could be a contract change and all this other red tape that they've got to jump through to make a change on something. So
yeah, and I will tell you that coming from an OEM and working with suppliers, those are major things. When you want to go into changes, especially major technology changes, it takes a long time to do that. It really does. You're contractually, you're trying to get contracts in, but then you're dependent upon your supplier to inject those changes, and you don't have control over that. even though you may put it into your requirements for whether it's a traction system or a battery pack or something else, that doesn't mean that you're going to get all that. That just means that you're putting into your requirements. If you think the supplier can do it, you sign with them, but that doesn't mean that they're going to be able to pull everything off. So, I mean, there's a lot that goes into that Tesla doesn't have to wade through all that mud to try to get to the other side. They just say, this is what we want to do. They will call in that group and say, this is what we want to do. And then they just do it.
Mm-hmm. Yeah.
So much easier to work that way. So I'm sorry to kind of take the long way around your initial questions, but I wanted to maybe set the stage on why they're able to do things that they do.
Yeah, no, that's great. I think that this is very, very beneficial. So let's talk just a little bit about this new battery. They've got this new design. It's a fatter battery. It's a little taller than what they're currently using. And the other takeaway here is that I noticed that they were also claiming that now this massive battery size, when they assemble it in a complete structure, it provides some structural type strength too. So what can you tell us about that?
Well, first of all, what they've got on tap here is they've got I've actually taken a look at the patent for their tabless battery, and they don't have everything within their patent, which most people don't do anyway. But they've got their patent there. But let me give the benefits of the tabless first. In a typical, like an 18650 battery, or even in the 2170 battery, you've got a tab that's connected to the plus and minus inside of the cylindrical cell. And all the current has to go through that small tab to get out. And so what happens is you end up with a lot of heat at that tab, but you also end up with a lot of bunching up of the ions trying to get in and out. And it chokes it off trying to get through that one cell. So what Tesla did is they said, okay, well, let's get rid of that small tab that connects to the top and bottom, the plus and minus of the battery. And let's take that tab and let's run it along the, entire length of the jelly roll. And so what they did is they were able to reduce the resistance of the cell. And so they've gone and I'm just going to kind of spitball the numbers here, but let's say they've gone from maybe 20 or 30 milliohms down to 5 milliohms, something like that, a really low cell resistance. And then that gives them, according to their what they have claimed, is that they're at 6 times the power. And power is just the rate at which you can deliver the energy from the battery pack. So really, when you're talking about 6 times the power, you're talking about a lower resistance of the cell. And that's huge, because when you can either produce power out of the battery pack at a lower resistance, or when you're charging going the other way, it reduces temperature in the battery pack, which that's huge. I mean, temperature is everything. The thermals inside of a battery pack are everything. So if you can keep the temperatures lower, you can not only deliver more power, you can also, of course, going the other way, you can charge and there'd be less temperature during charging. So they're claiming 6 times the power, which means translated, that means that their cells have lower resistance, that's a huge thing. I mean, forever, the 18650 battery's been around a long time. It's a very stable format. And the problem has always been, gee, we gotta, put this jelly roll together, and then we're going to try to send it out through this really small tab out to the positive and negative on both sides. You've got a tab there. So they've really gotten around that by going to their tabless design, which also means then they had to come up with some manufacturing that would allow them to do that. So they actually had to change the manufacturing of the cell. So what they do is they laser cut the foil and the cell, so they can actually bunch all that up inside of the cell much differently. It looks like, when I looked at it, it looks like a bunch of shingles, from the top.
Yeah, I saw that.
But yeah, so what that allows them to do is it allows them to roll their battery differently, so that they can get all of the energy out through the ends of that jelly roll. So they've really done a great job in getting around one of the problems that has plagued, the battery industry for a long time, is this little tab. Now they're going along the entire length of that jelly roll. So what that does for them is it distributes the heat evenly in the battery instead of having all the heat go out from the center out to the outside. So when you go to reject the heat in a battery with a tab, because the tab's in the center of the battery, to get rid of the heat, all the heat has to go out toward the outside of the can that the jelly rolls in, which means you end up heating the battery. You end up heating the whole thing. So when you go to the tabless design, what you do is you actually distribute that heat very evenly across the battery, which gets rid of all the hot spots within the jelly roll. So it really, it's quite amazing what they've done with that battery, which is going to drive innovation. That's going to drive innovation into the rest of the market. So there'll be companies that'll, they're going to be playing catch up on that as well with that. So it's quite the battery. Also, they're claiming 16% range increase by doing that. They do that by volume. So they're also claiming five times the energy in their battery, and that's not the energy density. And that's where terminology comes in. They're not saying 5 times the energy density. That would mean you get 5 times the range, which that's not what you're going to get. What they're talking about is five times the volume. So they're going from from 18650, like in the older S model, to a 2170 in the Model 3. Now they're going to a 46 millimeter by 80 millimeter format in their newest battery. So they're increasing the volume, and they're saying they got 5 times the volume. So it's very impressive because they're able to do a lot of things in their manufacturing because they own the manufacturing. This is the thing about being vertically integrated. They own the manufacturing, which means they can change manufacturing on the fly. They can just say, okay, this is what we want to do. They'll research it. I'm sure they're leveraging SpaceX for some of this, and then they'll say, okay, let's do it. So there's a lot of advantages there for them.
Yeah, that's a good point. On when you see just some of these raw numbers, right? When they say 6 times the power or 5 times the energy, but they're not saying energy density, which is very important. And for some of us that are not engineers, so that is the power with the mass of the unit that's delivering the power, right?
Yeah. The energy density would be, and when you talk to a battery engineer, they'll say, well, their primary target is watt hours per liter. So in other words, that's how many watts you can store for the size of the unit. That's their biggest target. Then watt hours per kilogram, which would be the weight of a battery, is actually secondary. So what Tesla is able to do is they're able to get more watt hours per liter, so to speak, with their batteries. And so they've done a lot of things here. They've gotten rid of thermal problems by going tabless. They've increased the density. They're saying they're increasing their range by 16%, which means they've increased the density, but they've increased the volume. So going to a 46 millimeter by 80 gives them more volume. So, they're able to do that. And there's a number of other things they've done within the manufacturing of that cell. Also, they've been able to go away from when the cells are manufactured, they've gone away from wet technology, which means you have to use solvents and things to roll your jelly roll. They've gone to a dry, which means a dry manufacturing process, which means they've gotten rid of the step in there that you have to use solvents in order to. They've gotten rid of the drying process.
Yeah, that's huge.
It is, and they've gotten rid of that step, which means these are all things that add up to how they've been able to reduce the cost. And Tesla has a very holistic view of their vehicle. They look at everything from the battery pack to the motors and they roll the manufacturing in. So their enhancements are a holistic viewpoint. It's not just the pack or not just the motors or inverters or the body. It's a holistic thing with them.
Yeah. So one of the other things that I noticed, thank you for mentioning the process, right? Because everything has a cost to it. So they look at it, and they go, "Oh, we can do this, but what is the cost, right?" And
Right.
so then they could start distilling that down and start changing the way that they want to approach it. One of the big notable things from that battery day was talking about the use of silicon.
Yep.
And they were talking about the desert, and they were just pulling the silicon out of the dirt, taking it away, and then putting the dirt back, which means a minimum footprint. That was their simple description. But can you shed any light on that?
Yeah, sure. Well, if you take a look at it, outside of hydrogen, silicon's probably the next largest element that we have because it's sand. It's basically sand. So what you do is you remove the silicon and then you process that. You move it out of the earth. Then what you do is you process it into a powder, and then you take that into your manufacturing plant, and then you roll that into your jelly roll when you make it. So you put that into your anode of your or the negative terminal of the battery, and you roll that in. So there's an abundance of silicon there. And so it's very easy to extract. And because, again, Tesla is into manufacturing, they can do that. Normally an OEM would be reliant upon their supplier to do that. And the supplier may be reluctant to do that. As part of their contractual arrangement, they may be reluctant to do that, but Tesla can do that. So the reason that the silicon is so important is because the silicon, what you do is you add that into with your graphite on your negative terminal of your battery. So on the anode or on the negative terminal of your battery, you add in the silicon. And what the silicon does over the normal graphite is the silicon can store anywhere from 7 to 10 times more lithium than the graphite. Now, this is really important because when you're talking about the energy density of a battery, you're talking about how much lithium can you hold. That's really what in that can. And so with silicon, you can go like 7 to 10 times on the amount of lithium that it will store. And so you end up storing more lithium, which means you have more energy density, which means you have more range on the vehicle. This is the key. Now, the downside of adding the silicon to the cell is that it expands anywhere from 4 to 6 times normal, which means you can end up getting expansion stress or some type of cracking, which will end up into some type of electrical isolation in the cell, which means, bottom line, you lose capacity. So the real key for adding the silicon into the cell is how much do you put in there, and then how can you control the expansion? So you may need to use some other metals to do that, and that's a very secret sauce type of thing. Nobody ever talks about how much silicon they're adding and how they're doing it, because that's the real key. It's all about lithium storage. So the silicon is an enhancement to that. So if you want to add 3, 4, 5, 7, 8%, whatever that number is of silicon into your anode, which would be your negative electrode, the more that you add, the more capacity you get, which means the range of the vehicle goes up. So Tesla's finding ways of adding silicon to their batteries in which others aren't able to do, because again, Tesla controls their manufacturing, which gives them a huge edge on others. So it's a big thing.
Yeah. So let's talk just for a minute about, their strategy behind, they just basically laid their cards on the table, so to speak. And that they're probably holding some more cards in the back end here, but
oh, right. Yeah.
And they probably have been working on this new technology for a while, but now they've revealed it, right? And how long do you think that they've had this in their back pocket?
Well, if you take a look at the patents, and I think I'm going to be right on this, but I think their patents go back to 2016 and 17.
Okay.
So they've been holding this for a while. There's 3 guys that are actually on that patent. I can't remember their names off the top of my head, but this is going back like maybe 3 or 4 years. So they've been working on this for a long time. And I think what they did is they really identified they're very good. They are very, very good at identifying where the bottlenecks are. And that they're very good at that. And what they do is they go after those bottlenecks. Let me give you an example of how they do this. So and again, this is a holistic type of process that they use. So if they want to heat the inside of the vehicle, a lot of companies will use a PTC heater, high voltage PTC heater. They heat the liquid, you pump it through the heater core, the fan blows it into the passenger compartment, and then you get warm. And same with the battery pack. Most OEMs today use a very conventional approach, and they use a PTC heater, whether it's 2 kilowatts or 3 or 5 or whatever their heater is for the battery pack. And they do the same thing. They'll heat liquid, and then they'll pump it into the battery pack to heat the cell, because the cells, of course, are very lethargic when they're very slow and lazy, when they're cold. And also, by the way, when you're cold with a battery pack, it makes it very difficult to fast charge it, because you end up with lithium plating on the cell, which means you lose lithium ions in the cell when you fast charge at a cold temperature. So the key is making sure that the cells are warm when you charge them or when you want to use them. So one of the things that Tesla does is and I actually got this information from Monroe and Associates. I haven't checked this myself, but I trust Monroe because they're probably the premier benchmarking company in the world, and they're right in the Detroit area. What Tesla does is they lock the rotor of the motor, and then what they do is they use the heat generator from the motor, and they'll pump it into the battery pack to heat it, which is very smart, because that way you don't have to have a separate PTC heater, and the motor is more efficient than the PTC heater. So doing a locked rotor, locked rotor means that the rotor inside of the motor is not spinning, but you're pumping current into the stator. And so when you pump current into the stator, you're going to develop heat. And then, of course, then the coolant jacket then is going to take that heated coolant, and then you pump it into the battery pack, and you warm the pack that way. So instead of using separate type of systems, they will use a more holistic approach again. And they'll say, what do we have on the vehicle that we can actually use? Instead of having these extra parts, what can we do with this thing? And locking the rotor on the motor is one way to do that. And so they've done that. And that's just one of the things that they do that others don't do. And there's some other things you can do with the locked rotor that I don't think that they're doing yet. But I think if I were to sit down with them, at least for a half hour, I'd say, gee, as long as you're locking the rotor, why don't you do this, that, and the other thing with it, because it's free. I mean, it doesn't cost them anything to lock the rotor and then take that coolant and then run it through, to the battery pack.
Yeah, that is amazing. And you mentioned Monroe. So Monroe and Associates, that's Sandy Monroe for anybody listening. He's a guy that I follow a lot. He's got like these YouTube channels, and he's done a lot of breakdown on Tesla in general, and actually has gotten their attention. He criticized the Model 3 construction, not to get too far off the subject, but he talked about the construction and how many fasteners and how many pieces, and he said, this is ridiculous. And now they launched the Model Y. He took the Model Y, stripped it all down, and discovered that they went to a single casting for this rear compartment. And he goes, oh my God, this is awesome. This is what I was recommending.
Yeah, and by doing that, they got rid of over 300 parts by doing that.
Yeah.
I mean, just by going to it's amazing. And again, I get back to this vertical integration thing, but this is so important. And I know a lot of the listeners may not have a manufacturing background, which is fine, but to have that flexibility to be able to say, oh, we're just going to go do this. You know what I mean? It's huge, because you can't do that. And other companies can't do that because they're dependent upon their supplier. So that is a big thing, going to a casting that big. And then you also mentioned, I kind of got sidetracked here, Scott, and I'm sorry for that, but you got into the batteries being a structural member of the vehicle.
Yeah.
And that is another huge thing, although that has been done somewhat by other OEMs. in the past. But what Tesla has done is they have not only integrated the battery pack as a structural member, but they also locate the battery pack so that you've got good center of gravity.
Mm-hmm.
So I mean, they've kind of gone a little further. They said, okay, we're going to do this as a structural member of the vehicle, which is good because that actually adds to the stiffness of the vehicle. I mean, it's really good to keep the battery stiff. And we could talk about how that affects the battery pack and other things that they've done inside the pack as well. But keeping the battery pack stiff and then centering that in the vehicle really gives you good feel on the vehicle. So they've done a couple of things. They make it structural, but they also place it where you get good gravity, a center of gravity on the vehicle. So it's low and it's centered in the vehicle. So you really get a lot of good feel out of the vehicle. So they've done a very good job of not only, developing a new battery cell, but also placement in the vehicle. And then how they've done that and made it a structural member. So they've really knocked, they've taken one stone and knocked a bunch of things out with it. So it's actually impressive to see that.
Yeah, it is pretty awesome. They have that very low center of gravity. It definitely changes the vehicle dynamics and, of course, the stability, right? So if the car's, in a position where maybe it got in an accident and it's sliding sideways, it's a little more reluctant to actually roll over than say a vehicle with a higher center of gravity.
Correct.
So yeah, that's a great perspective on that. And so you talked a little bit about the motors, and how they're actually locking a rotor and creating some heat. But one of the other things that I've noticed, Tesla is doing some remarkable things with their motors, and something I was reading about recently. They're talking about induction motors versus what's called a synchronous reluctance motor. What can you explain at a high level for us on that?
Okay, so very high level. Let's just start out defining the two motors. So an induction motor does not have permanent magnets on its rotor. It has no magnets on it whatsoever. And you can either use a copper or an aluminum rotor. And the way those work is that you take the stator windings and think of it this way. Think of a transformer, because that's really what it is. An induction machine is a rotating transformer. So for the automotive guys that are listening in, they're working with transformers every day with ignition coils. I mean, those are step-up transformers. So you step up from 14.5 volts, it gets stepped up to whether it's 30 or 40 or 50,000 volts, it's stepped up. Well, the induction machine is the same thing. You have the stator, which is your primary of your transformer, and the rotor acts as your secondary. So what you do is you take the primary and then you magnetize the rotor with that. Just like you magnetize your ignition coil, you expand magnetic fields off the primary across the secondary. You're magnetizing the secondary by doing that. And then you're expanding and collapsing the fields to, increase your voltage from 14 up to, let's say, 40,000 volts to fire your spark plug. So it's the movement of the magnetics that gives you, the power to do that. Well, the induction machine's the same way. You take a current, you run it through the stator, and it's in the case of Tesla, it's a three-phase induction machine, and others too, but they could be 6 or 9 phase. But in the light duty market with cars and light duty trucks is typically 3 phase, but it could be 6 or 9. But so the stator's the primary, the rotor's the secondary. So what you do is you magnetize rotor bars that are inside of the rotor. So the rotor bars could be 40, 50, 60, 80 rotor bars. Those get magnetized, and those act as small magnets as soon as you magnetize them. So what they do is those rotor bars then interact with the stator, and what you do is you switch the stator coils in a circular direction. And because the stator has north and south poles, and now when you magnetize the rotor bars in the induction machine, those are north and south poles, so they attract. So you get to rotate the rotor because it's magnetized now with north and south pole, just like the stator is. So you get push and pull, the rotor in a circular direction because the stator is being switched in a circular direction. So you're firing the coils in a firing order, just like you do in an engine, and you do that in either a clockwise or counterclockwise direction. So let's say clockwise, you're going to move the vehicle forward. Counterclockwise, you could run the vehicle in reverse. So you have to magnetize the rotor to do that. So that's an induction machine. So you induce currents in the the rotor by magnetizing the stator. So stator magnetizes and the rotor magnetizes, and the rotor chases the stator field around, and that's how you get your speed. And then you vary the current going into the stator, and that varies your torque. And you also vary something called slip. And the slip is the difference between the switching speed of the stator and the rotational speed of the rotor. So if you want zero torque, you pull your stator current back and you pull your slip down to 0%. So you wouldn't get any torque. If you want high torque, then you take your currents and go up to 100, 200, 300 amps, and you increase your slip up to a maximum of 15%. So as you go up toward 15%, you're burning the wheels off the car when you do that. It's tremendous torque in an induction machine. And then conversely, you can do the same things in regen. If I go to minus 15% slip on an induction machine, you can actually put the car right up on its nose. It'll lock the axle up and go right up on its nose. So you have to have a lot of controls on both the propulsion and regen side. Now, when you get over to the permanent magnet machine, which Tesla uses permanent magnet, like on the Model 3, they use an induction machine on the front, and they use a PM machine, permanent magnet machine, on the back. And it's called a reluctance machine because there's two types of torque that you can generate in a permanent magnet motor. You can produce magnetic torque, and then there's reluctance torque. And without going too far down the rabbit hole, basically you're using a design in the motor to have additional torque produced through some paths that are between magnets. You actually put some metal teeth between the magnets to permit magnetic field to go through these teeth. So instead of having an air gap to go through, you actually design the motor where there are some parts of the laminations of the motor that allow you to send magnetic field through some teeth, and you actually get an additional torque kick out of that. So you get magnetic torque just through the magnets, but then you also get reluctance torque through the path that magnetic field takes. So you actually get additional torque. So that's why it's called a reluctance machine, is because it's using some additional paths for that magnetic field to go through to increase the torque. So that's what you have on the rear motor of, let's say, a Tesla 3. Now, the advantages, let me give you the advantages and disadvantages of these. The advantage of the induction machine is that it has a very high peak torque on startup, really high peak torque. And so you can also run induction machines at over 100% of its rated power. So you can go, 110, 120%, and they'll still survive. So you can really get a ton of torque out of those machines and run them at a higher temperature without the concern about demagnetizing a magnet, because the induction machines don't have a magnet in them. So there's a lot of advantages there. So that's the advantages there. The problem is that the induction machine runs at a lower efficiency. It runs at probably somewhere between, let's just say 3 to 5% less efficient. So the pro is that you get tons of torque out of it, and you can really run that thing, till its tongue is dragging without ruining it. But the downside is you have a lower efficiency. Now with the rear motor, like on the Tesla Model 3, they're using that permanent magnet reluctance motor that runs again at a higher efficiency. And I think I read something not too long ago that Tesla's claiming that they're reaching 98% efficiency on their rear motor. So induction machines are typically somewhere between let's just say 90 to 95% efficient, somewhere in there, depending on the metals that you use and how it's designed. And then PM machines are typically somewhere between 94, 95, 97, 98% maybe. That's what Tesla's claiming. So what Tesla does is that on the Model 3, they'll use their induction machine to launch the vehicle. In other words, to accelerate. And then what they'll do is they'll switch over to the permanent magnet machine, like during cruising. So what they're doing is on the two motor system is that they're using the advantages of both machines. They're using the high torque of the induction machine to launch the vehicle, and then they use the permanent magnet machine that is more efficient for cruising. So they're getting the benefits of both worlds there.
That's interesting. I just learned something there. So thank you for that. That is amazing. I was trying to figure out, why would they use two different motors?
Yeah, it is. It's amazing because they make their own motors, of course, and the Model 3 uses a copper rotor in it, and copper rotor will give you a higher torque than an aluminum rotor, which I think that's what Sandy Monroe said. I haven't looked at a Model Y yet, but he claims that the Model Y is using an aluminum rotor. Now, the advantages and disadvantages of that is copper is heavier, it costs more, but it gives you higher torque because, aluminum's got like 30% more resistance in it. So, you can get a higher torque because you can push more current. So you get a higher torque that way. However, the aluminum is, of course, lighter, and it's a lot less expensive. So they have gone to the aluminum rotor. According to Sandy Monroe, they've gone to the aluminum rotor in the Model Y, which means you can reduce costs that way. And Tesla, because they also have material scientists there. I'm quite sure that their rotor is unlike anybody else's rotor. I'm sure that they have been able to reduce some of that resistivity in the motor. And so they're probably running a higher efficiency induction machine, let's say when you compare it to somebody else's machine, whether it's Audi or Mercedes or somebody else that's using induction machines in their EV. So lots of advantages to the way they've got that set up.
Yeah, that is interesting, and hence what you said about the tie-in to SpaceX, right?
If I could add one more thing, Scott, I hate to blather on about this, but Tesla has a very unique magnet that they use in their motor. It's called a segmented magnet, and this is very important because others don't use segmented magnets. What they do is they take layers of magnets and they bond them together to make a magnet. And of course, they got a lot of magnets within their rotor, but I'm just going to talk just like one of those magnets. So they bond them together in layers. And what we thought at first was that Tesla was using some type of Hallback arrangement, and that Hallback is spelled Halbach, Hallback, a Hallback array. And a Hallback array, what it does is it actually increases the Tesla, and this is not Tesla the company now, we're talking about Ørsted's or Tesla's strength of a magnet. And it increases the strength of the magnet by, you take the angles of the magnetic fields and you change it to make the magnet stronger. So what they do is they take the magnet and they sandwich these layers in. And what they found out, or at least, again, this is Sandy Monroe's R&D, but they found out that it wasn't really a Hallback, but it's kind of like a Hallback magnet. And for those that are interested in looking more at Hallback magnets, there is a great website to go to. It's called, if you went to Google or Bing or whoever you're using, just type in Super Magnet Man. I know it sounds hokey, but type in Super Magnet Man, and then it'll bring up a bunch of videos, and then pick on their video on Hallback arrays, and they go through the entire discussion about Hallback and why the Hallback arrangement makes a magnet stronger. And the key to what Tesla does is that it may not be Hallback, but it's something similar to Hallback. So they get higher magnetic field strength, which results in higher torque out of your motor. So they were able to get more torque out of their rear motor, like in the Tesla 3, because they're not using higher currents, but they're using the we'll just call it like a quasi Hallback arrangement. So they were able to get more torque out of their motor over a competing permanent magnet motor because of the arrangement. Now, what Monroe found out was it wasn't so much the magnets being sandwiched together. It was the material that they were using to bond the magnet layers together. And when Monroe took the magnets out and took them apart, once they were able to break the bond, they said the magnets flew apart, which that's what led them to believe it was a Hallback arrangement. But they later learned it wasn't quite a Hallback, but it's something like a Hallback. So to understand that more, I would tell your viewers just to go to Super Magnet Man and then click on the Hallback array and take a look. It's like a 20-minute or maybe a 30-minute tutorial on what Hallbacks are. And it really is interesting because they're able to get a higher torque out of their motor without a penalty in more current.
That's some really great information, Mark. I really appreciate that. So let me just segue to something else that, of course, you are heavily involved with, and that's education. And we're talking to a lot of our workforce here. In the future, technicians are going to start to see these technologies coming into the into their work bays. And there's, you keep talking about technology gap. There isn't a lot of transfer from what we know today about some of the mechanics into what's happening with the motors. And just listening to what you were just describing on the motor operation, magnets and battery construction, it's just absolutely fascinating. I know that your company, you guys provide instructor-led training, and you also have a lot of on-demand type training, so video training, which is awesome because here we're in COVID and we can't always go to instructor-led training. Tell me a little bit more about what you're doing there. What unique things you're doing. I know you're doing the boot camp stuff, which I attended, which is just absolutely awesome. Tell me a little bit more about what you guys are doing.
Okay, well, let me give you kind of a backdrop here. For those who I'm not acquainted, I actually started my career as a technician. When I had gotten out of the military, I'd actually gone into work in the aftermarket and at dealers. I kind of wrenched my way through school when I first started, and always had an interest in cars. So I actually started as a technician many years ago. So I have a love for technicians because that's the way I think. I'm opposite of the normal engineer. Normal engineers think from A to Z, and I think from Z to A. I go the other way because I'm thinking whenever I see something, I'm thinking, okay, well, how does a technician really, kind of interface with this thing, or what do they do with it? And so I'm always thinking the other way. And so that annoyed a lot of my colleagues through the years, you know what I mean? Because I'm always looking at it from the, the other direction. So I wanted to make sure that your audience understood that we're looking at everything from the technician point of view first. Is when we're talking technicians, if I'm working with engineers, I'm working from A to Z. But if I'm working with either technicians or field service engineers, I'm doing it the other way. So that's, I think, an important aspect of that. So I have my own company, Quarto Technical Services, that works with OEMs and remanufacturers. And so that part of my life doesn't work or doesn't interface with the aftermarket. However, Future Tech Auto does work with the aftermarket. That company is owned by my daughter, and I happen to be just a sweaty that works for her, so I'm working for her, but that company does interface with the aftermarket. And so we have tools and equipment and training for the aftermarket that we've developed over the years that could be utilized by the aftermarket. And what our products do, it might be a little different than others, is that we teach the technology first, and we go after product specific stuff second. And the reason that that's important is, and I know you know this, Scott, I mean, most people do, is that if you understand how something works, you can apply that to a lot of different things. It doesn't matter, once you learn how, we were talking about motors a little bit ago. Once you understand how motors work, being able then to take that further and get into the diagnostic side makes it much easier, because you understand the failure modes of it. Because usually in some type of motor class, they're going to go through, construction of the motor and, how it works, and then they'll get into failure modes. And it really helps to understand what's going on behind the scenes with the way that they work. It really helps diagnostics. And that's kind of what we do with our coursework, whether it's our on-demand stuff or in the classroom, is that we will go through the technologies behind everything, so you can apply it across OEMs. It wouldn't matter, quite honestly, if it were a Tesla or if it were a Ford product. What we do goes across the board. Now, there are subtle differences, like we've been talking about today with Tesla. There are subtle differences there, but those can also be weaved in. And what we do is we take the technology part of it, and then we weave in the product knowledge. So whether it's a Toyota or Lexus or Ford or GM or whoever it is, we'll start to weave in what they do. So technology is first, because it can be applied across the board. Product knowledge then becomes second, because we can then weave that in. It becomes much simpler. It's much simpler to learn the technology first and the product second, rather than trying to do it the other way. I mean, I've seen this for years, and worked with technicians and engineers both. And it doesn't matter either way with either group. It won't matter. If you get the technology first, it makes working with a product simpler, because you now know the things to look for. So it's really, that's how we do it, whether it's our electrification courses, in whether it's batteries or power products or electric machines or whatever it is, or air conditioning. It doesn't matter. We teach the technology first, then we spin it, and then we start weaving in the product.
Yes.
So that's how we do it. And we do that whether it is our boot camp stuff or whatever, or our electrification on demand or live training. So we're slowly pivoting toward the virtual, because with our stuff, it was, most of our coursework is not just a lecture type of thing, but we start doing a lot of things with the vehicle, and we spend time on the vehicle doing it. It's very difficult to, especially on the safety side, it's very difficult to try to transfer that virtually to somebody that's on the other end. So we're slowly doing the virtual pivot. We're still going to have live classes, but our first virtual is going to be our boot camps, which starts in the first quarter of next year, which we will send all of the parts, pieces, and everything to someone. And then we will have dates which we'll get on together live, and we'll actually do our stuff that you did, like in the live class, but we're going to do that virtually. And they actually get a webcam and everything with their kit, so I can actually see what they're doing with their circuit. So I can help them if there's something that's not working on it. We can actually help them out by looking at the webcam.
Awesome. That's a very cool strategy there. I think a lot of guys can appreciate that. And going back to having a deep understanding of how the technology works, yes, definitely. I mean, I've learned a lot of stuff. I've gone over the edge of taking a deeper dive into certain technologies. But now it doesn't matter if it's on a Mercedes or if it's on a Volkswagen or a GM product. They're all kind of doing the same things. Each of those might have their different subtleties about how they go about it, but you as a technician are going, okay, now I understand what the engineer was trying to do. Now why isn't it not working, right? So
right,
yeah, that's
and the diagnostics, actually, when you get into the diagnostic side, when certain parts of the electrics have a better stack of PIDs for the diagnostics. I mean, they just do. And there are other parts of the vehicle that don't. The battery pack is really good on PIDs. It's really good on because that's the battery pack is 40% of the cost of the car. Depending on whose car it is, it's 40 to 50%. So you're looking at a huge part of your cost with the vehicle. So there's a lot of data PIDs, whether they are just status PIDs that are telling you yes, no, on, off, or they're actually giving you data PIDs, or if they're doing C PIDs, which are control packets, which are allowing you to send CAN messages from the scan tool to the controller, and then the controller runs an algorithm to do what you want it to do, whether it's turn on an EGR or turn on an injector, or in the case of the battery pack, it might be something else you want to do. So there's a lot of PIDs built into that. But when you get into other places on the vehicle, there aren't as many PIDs. So you have to become a little bit creative. So if you root yourself in the technology first and how to test technology, then it doesn't matter how many PIDs you have on the scan tool. There's other ways of testing things. You just have to know how to manipulate it. And so that's one of the things that we go through in our courses, is that we actually go through, how can we do this? Can we take the car on a road test and waveform a motor, which you can, or waveform the inverter, or are there some other things to test out the, like the motor? We were talking motors. So, there's other ways of testing out the motor without using scope. There are other off-board ways of doing that, using some motor circuit analysis tools. And so if you understand that type of stuff, if you get it underneath the umbrella of technology first, it doesn't matter what comes through your door after that. Because if the scan tool doesn't give you enough, if you're saying, gee, I sure wish I knew this or that or the other thing, and I'm not getting it off the scan tool, what we teach in our classes a lot of times augments the scan tool. And so it gives you another set of tools to put in your toolbox, so to speak, for diagnostics. So it's important. It's so important that the technicians get a firm understanding, because the gap, I will tell you, if I were in a class and I were to ask somebody, well, tell me how you would test out a fuel injector, or how you test out the fuel system. Well, we take pressure, volume, we can look at, if you take them out, you can look at how they're spraying, or you can test their resistance. You can look at the scope, for what kind of transient spike you get out of them. The technicians can tell me 100 different ways of how to test a fuel system out. They can give me everything. They can give me a current ramping on the pump, everything. They give me everything. But then if I turn that and I say, well, tell me how you would test the battery pack out. How would you do that? Besides the scan tool giving you information, how else could you do it? Or how would you test the motor out? How would you do that? And I get silence. And I'm not picking on the technicians here. I'm showing you the gap. I hear nothing but crickets when it gets into the EV side of it. So I know we have 150 years of experience with the internal combustion stuff, going back to the late 1800s all the way up till today. So we have built a huge chest of knowledge about those systems. They've iterated over time, and the technicians have done a great job of keeping up with, a lot of that technology. The problem is there's really no technology transfer between the internal combustion engine vehicle and the electrics or the plug-ins. There's not. It's like you're starting with engines 101 all over again, because there is nothing to transfer. The same with the legacy knowledge. We've used over the years, we've had changes with the vehicle, and we've been able to utilize prior knowledge to be able to leverage the new stuff. So when somebody comes out with a new X, Y, or Z thing, and it usually is an enhancement of something else. So we are able to use previous or legacy knowledge to get us to the new stuff. Well, with the electrics, you can't do that, because there is nothing. There is no EGR on them. There's no fuel injectors on them. There's no evap systems on them. There's nothing like that. It's all new stuff. So I would almost beg the technicians to start learning about these, because the hybrids have the same. It doesn't matter. Hybrids have been in our market for 21 model years now, and they have systems that are similar to electrics. A lot of the stuff ports over, And I know that the hybrids have been out there for years, but there's still so much that is misunderstood about those or unknown. And then when you go to the electrics, there's even more systems on there that are certainly less understood and unknown. So it's really important, I think, for the field to understand that this will be something that's new. I think they have time yet to do that, but these systems are going to be coming on very quickly in the 2020s. I'm talking electrics, and the hybrids have been sitting out there for years. So, I mean, certainly you could get the hybrids into your shop. If you're not doing them today, you could get them into your shop and there'd be another revenue stream for you. And that's good. But the plugins in the electrics, we started, this goes back to the Nissan Leaf back into the earlier 2000s, 2011. So they've been in the market 10 years already, and the aftermarket is seeing those vehicles along with others, and they're really not understood. So I would say learn the technology. It's fine to know some information about Nissan or Ford or GM or Tesla. That's fine. But learn the technology that's underneath them first. That will make learning the products so much easier. It makes it super easy. It's like this. If you're going to take a math class, I wouldn't throw you in calculus first. I would throw you in, general math first. I mean, that's kind of like what it is. When you get into that, you really need to understand the underpinnings of something first before you get into the more advanced stuff. It's really important to understand those fundamentals.
Yeah, it's clear that there's going to be some huge challenges, in the future. But whenever I see challenges, I always look at that as an opportunity. And
absolutely, yep.
You jump on this and start getting ahead of the curve. And you're going to become the go-to guy, right?
Correct.
And you're ready for the next wave. So, well, great, Mark. We've covered a lot of ground. I know there's a lot more we can definitely talk about, and I hope to do that again with you in the future. You've provided our audience here with a tremendous amount of perspective, and I appreciate you sharing your vast knowledge on these advanced powertrains. And enlightening me as well. So I'm really blessed to have you on the show today. So thank you very much, Mark.
Well, Scott, it was my pleasure. I enjoy doing this, and I'm getting to be an old man now. So I'm going to continue to do this until I hang it up. But I really enjoy doing this. I enjoy at least giving the perspectives, and I thank you for the opportunity for coming on today, because I know that you touch a lot of the technicians and others, not just technicians, but owners and others in the field. And this is a good way to get the word out. But I appreciate so much you inviting me on, and thank you.
Hey, you're welcome, and we'll do this again. So look for the show notes. We've got a lot of links and things that we talked about there. I'll have a summary. So thank you again.
Thank you.
That brings us to the Industry Events Roundup. Leading automotive industry organizations from across the U.S. have joined together and created the new training event PAVE, P-A-V-E, which stands for Professional Automotive Virtual Education, which promises to be the ultimate virtual training event for automotive professionals. The PAVE training event is powered by both CarQuest Technical Institute and Worldpac Training Institute. The virtual training will take place over 3 days, beginning Friday, January 8th, and will run through Sunday, January 10th. Shops will enjoy the best and top trainers in the industry teaching more than 30 live training sessions. The Vision High Tech Training and Expo has announced its 2021 event will transition from an in-person event to a virtual event. The 6-day training event will span across 2 weeks, consuming 3 days each week. The event will start on Tuesday, March 2nd, and will conclude on Thursday, March 11th. Visit visionkc.com for more information.
Hello, Newman.
And this bit of feedback came from Matthew Potter in Nova Scotia. Matthew writes, "Hi. Just wanted to reach out and say thank you for using my case study in episode 7. Love your podcast content, interviews, and topics. I haven't found another one like it. Keep up the great work. Matt." Well, thank you, Matt. We appreciate your feedback. And anyone else listening out there, we'd love to get yours as well. Email podcasts@vehicleservicepros.com. Now that brings us to the end of the show, and we hope we are able to bring you some quality content. and we thank you for joining us. And we're looking for your feedback. So if you have any questions, comments, or suggestions on future topics and/or featured guests, please drop them in our mailbag.